Hey everybody, welcome to my video on product differentiation with the Salop circle. What we're going to be doing here is I'm showing you a new model. I'm not going to get into any complicated pricing or location questions. I'm just going to say for a given number of identical symmetric firms, how do consumers respond, how many consumers go to each, and what's the number of firms that lowers the average cost in the market the most. So, let's introduce our model. This, you can pretend that's a circle with a circumference of 1. Doesn't have to have a circumference of 1, but it's an easy assumption that no one complains about. Making it bigger won't help you at all. And it represents our product space. It could be a measure of how far places are physically from each other, or it could be a measure of product attributes, where different locations represent either different individual preferences or different firm product characteristics. So, without any further ado, let's get started. Let's introduce our firms. Our firms, I'm going to say that there are N of them. And each firm has a cost function. The cost at an individual firm being equal to F plus MQ. Now when we talk about what F is just a fixed cost that each firm has to pay to be in the market, and M is some constant marginal cost. You can make it non-constant if you want to. I'm not gonna. Let's see. Later on I'll do an example where N equals 3. F equals 100, and M equals 5. Now, I already told you, I'm assuming that these are symmetric firms. They all have the same cost function. The distribution of consumers is equal. We can trust that they're going to place themselves equally around the circle. So here's where one firm will locate. Here's where another firm will locate. And here's where the third firm will locate. There is 1/3 distance between them. Distance between firms is 1 over N. 1 over 3. Okay, now with all that said, we've pretty much introduced our firms. That's all we really need to know about them for now. Let's talk about our consumers. We need to have a certain number of them. There are L consumers, and these are all spaced equally. We call that uniformly distributed. And that just means that they are all spaced evenly around this circle. For our example later, I'm going to assume that L equals 90, because it pairs well with 3 firms. And let's see. Let's talk about how far an individual is from a firm. We're going to assume that a consumer will have a distance D distance from firm. So for instance, I'm talking about if I have a consumer who lives here, hey guys, and he lives that far, that would be D. That would be D to get to that firm. That would be the closest distance to a firm. And then we could go farther. How far do they have to travel? 2D. It's a round trip. They go there, and then they go back. Now this travel is costly. Whether it be measured in time or gas money or whatever, we need to have a parameter, T, which is travel costs. And I'm going to say C for travel costs is equal to 2DT. That's travel costs for one individual, and it's equal to their round trip distance times T, basically. For the example later, I'm going to say that T is equal to 4. Now, we've got these 90 people. We've got something about how far they have to travel to a firm. I'm going to make an additional assumption. Every consumer buys exactly 1 unit of the good. That is not a required assumption for these models, but it's a very helpful one. These things can blow up pretty quick if we don't have that one. So let's talk about these consumers real quick. Specifically, who's going to go to which firm? I want to talk about these consumers here that are equally spaced between the firms. Now these 3 consumers equally placed around the circle, anyone that is between this consumer and this firm will go to that firm. Anyone between this consumer and that firm will also go to that firm. Now, how many is that? How many customers? Well, that is L over N customers, which in this case is 90 over 3, is 30 customers to each firm. Now, what's that look like? That means that there's 15 here and 15 there. Now, likewise, there are 15 more who go to this firm from here, and 15 more who go to that firm from here. And there are 15 more who go there, and 15 more who go there. 30 to each firm, the 15 closest on either side. Now, what is the closest? Actually, let's start with the farthest. What's the farthest anyone travels to get to one of these firms? The farthest distance traveled is half the distance between firms. Each of these little stick figures is halfway between these 2 firms. But the distance between firms is n over 3, so the max distance traveled is 1/2 times 1 over n. In this case, that's 1/2 times 1 over 3, which is 1/6. This distance here is 1/6. No one ever has to travel farther than that. Now, if the distance is 1/6, let's not forget that the travel is round trip, is 2d, which is 1/3. There are people who will have to travel 1/3 round trip to go to their firm and buy their product. Now, for every person who has to go 1/3, there's someone who has to go 0. For every character like this, there's a character who lives right there. And additionally, there are more characters equally balancing each other so that we can find an actual average distance traveled for each firm. And so let's do that next. Let's say average distance. Let's see. The shortest travel anyone has is 0. The longest travel anyone has is 1 over n, in this case 1/3. And then we're going to take the average of those 2, which winds up just being 1 over 2n. And in this model is 1 over 6. So the average distance anyone has to travel round trip is 1/6 of the way around our circle. And so with that, we can actually build real total transportation costs. The total transportation cost is, let's call it, transportation cost for everybody. Oh, yeah, I called it travel cost, didn't I? Travel cost for everybody equals L times T over 2 times N. Now, what is that? That is L customers times travel cost per customer times the average distance. So that in this example comes out to be 90 times 4 over 6, which is 360 over 6, which is just 60. So in this market, in this Salop circle, with these 90 consumers, $60 are being spent on travel. Now I can similarly break down how much each firm is spending based on its cost function. And I'm going to add these two things up and figure out how many firms would minimize the total cost. Let's leave that up there for now as its own deal. Let's look at our firms now. The cost of providing a meal for all firms is going to be L times our marginal cost, because each firm buys one, so Q is L, plus N, number of firms, times the fixed cost. In this model, that is 90 times 5 plus N times F is 450. Oops. 450 plus 300 is 750. So right now, our total cost is equal to 750 plus 60 equals 810. Now, my question moving forward now, is there any way to lower the total cost to society? Now, it just so happens that out of convenience, I chose a good number, and no, not while having an integer number of firms. But let me show you how I would show that. I would build my total cost function is equal to C, the travel cost for everybody, plus the meal cost for everybody, equal to L T over 2N plus LM over plus NF. Now, in this specific example, that is going to be, let's see, that comes out to be 10 over N plus 450 plus 100N. If you graph that, it looks something like this. Total cost, where it comes down and then it goes back up and goes up and up and up. And so I'm interested in this point down here with the slope being equal to 0. So if I've taught you how to do calculus in this class, follow the next step. If not, you can skip to the result I give you. But I want to find the point where the slope is 0, where the derivative of this function is equal to 0. Now, how do I do that? Well, I can just use my power rule like always, but I want I want dTc over dN. I'm going to set that thing equal to 0 to get this 0 slope condition, and I will get negative LT over 2N squared plus F equals 0. So use your power rule. I've got another video on the power rule if you need to see it, but go ahead and check it out if you want to. And when I solve for N, I will get that N is equal to the square root of M times T over 2 times F. And with all of these parameters in this case, it comes out to being about 3.16. Now, that means we could get lower costs if there were 3.16 firms, but you can't really have that. You need to have 2 or 3 or 4, and 3 is the closest to it. So 3 is actually the lowest cost we will get in this market. 4 terms would take us farther from it and have higher costs. 2 firms would give us higher costs also. So this video is long, but I hope it was helpful. If not, too bad. Go read a book or something. Thanks for watching, you guys, and good.